How many mathematicians, students, do you really think understand the connection between Pythagorean theorem, having a hypotenuse length of 1, and talking about a unit circle where the length of the radius is also 1, where sine of 45 degrees and cosine of 45 degrees match the angles across from side A and side B? Isosceles triangle, isosceles triangle. Here's the interesting relationship. In this triangle, A and B are the same length because the angles across from them are the same. So instead of saying A and B, what if I just called them both D? And I had D squared plus D squared equals C squared. Again, Pythagorean theorem. D squared plus D squared, 2D squared, equals, well, C squared. We know that C, the hypotenuse, has a length of 1. So 1 in place of C, 1 squared. So 2D squared, 1 squared is just 1. Divide both sides by 2, so D squared equals 1/2. Now, to figure out the length of D, D is, you take the square root of both sides of the equation. So the square root of D squared is D, the square root of 1/2. And it will be plus or minus that. So let's stick with that for 1 second. The square root of 1/2 is 0.707, so on and so forth. So now I finished up by writing D equals 0.707 about. And we can ignore the negative one because obviously if it's a length it has to be positive. So A and B are the same. Now over here the unit circle, I drew the circle. It's a pretty poor rendition of the circle, but you get the idea. So the sine of 45 degrees is opposite over hypotenuse. The hypotenuse is 1. So essentially anything divided by 1 is the anything. So if I plug in a number here, that's going to be the answer. Same thing for cosine. Cosine is adjacent, or b over 1. So now I'm going to use my calculator again to type in cosine of 45 and sine of 45. And what do you think they're going to be if they're the length of A and B and these triangles are the same? The sine of 45 degrees is 0.707 ... The cosine of 45 degrees is exactly the same, 0.707, yada, yada, yada. I still say too many people who study this don't really make this connection for students. These are the kind of connections that I believe students need to make sense of math so they can continue to move forward and progress. Too many kids at this stage in trigonometry just assume that everything is there for a reason, but they don't really know the reasons. Please like and follow for more. I will have a long series on this on YouTube coming soon. Thanks.